Hi guys, this is lesson 6, our last lesson of the unit. This lesson incorporates some of the stuff we've done thus far in the unit, but also includes some stuff that you've done last year in grade 10. And so remember last year when you were given two equations for two lines and you had to solve it, so you were trying to see if the two lines intersected or if they were parallel or if they just never crossed or if they were the same line. So you had to do a couple things in order to try to figure that out. And we're going to do the same thing today, only trying to solve a system between a line and a quadratic. And it's quite similar in the way you do it, but it's also going to incorporate how we solve quadratic equations. And so remember here, if we wanted to solve this, we could do one of two things. We could use a method of substitution, or we could use the method of elimination. And if you forget those, that's okay. We really actually are going to use in a linear quadratic system, the first one. We're only going to use the method of substitution. And there's a reason why. If you have an equation that's set up as, let's say this was x equals, and I moved the 2y over, so it's 12 minus 2y, I could simply sub in the right side of the equation into the x of the second one. So it would be set up well to substitute this in. In a straight line that's in a standard form and a quadratic in a standard form, then it's set up already well to go with substitution. And so we'll get to that in a second. If we think about what can happen when you have a linear quadratic system, well, we can have a situation where we have two solutions. So we could have something like this, where I've got a straight line that's going through. I'm just going to add some arrows on the end of this. And the straight line hits the quadratic twice. And there's lots of applications of this in real world, and we're going to talk about some of them. You could have something where you throw it up and it hits a parabola-shaped thing twice, or you could think of it as a business model where you've got steadily increasing prices, and when is it going to match some other quadratic-related function. Anyway, we can have two solutions, something like that. We can also have a case where we only have one solution. That's a bit harder to draw. So if I do that one, it's only hitting it at one point, and I just see if I can move this so it does that. Something like that. Arrows on the end, and it's hitting just right here. That's what's called a tangent. So when something hits something just barely and it hits it once, we call it a tangent. And then there's, of course, this possibility where you have no solutions, and so the line is just below it, like this. And so one thing that's going to come up in this situation, or when we're solving things, is the idea where you have two solutions, one solution, no solutions. Do you remember before when we were trying to solve quadratics, we could figure out if there was two solutions, one or none, by using the discriminant. And if the discriminant was equal to 0, then we got one solution. If the discriminant was negative, we got none. And if it was positive, we got 2. That idea is going to come up when we look at this stuff going forward. So one sec here. So if I'm looking to solve this quadratic linear system, it says find the points of intersection of the following equations. You can still think of it as having two equations with two unknowns, but notice it's y equals this and y equals this. What's nice is that I can just substitute in one of the equivalent y's, so whatever's on the right equation, into the other y. Really, it's like setting them equal to 0, or sorry, equal to each other. So I'm going to take this and I'm going to set it up. So I've got 1 equals 2, negative 4x And I realize I've written them on the opposite order, but that's okay. Still going to get the same answer. And so I've got this setup equal to this one. This y is equal to this y, and that's going to allow me to see if there are any points of intersection. And so I need to rearrange it, and so I have everything on one side and it's in standard form. So if I do that, let's make the left side equal to 0. So I'm going to add 4x over. So I've got minus x squared, and then I add another 4x, I've got plus 10x. And then I'm going to subtract 19, so that becomes minus 24. Now I've got something in a quadratic form that I can use to solve, just like we've been doing throughout the unit. So we have two options when we solve this. We can use factoring if we can, or the quadratic formula. So let's see if we can factor it. The first thing I'm going to do is take out a negative. And so now we can look and say, okay, my a value is 1, so this is an easier factoring simple trinomial. And my c value is positive 24, so I need two numbers that multiply to give 24 and add to give negative 10. So factors of 24 would be 12 and 2, 8 and 3, 6 and 4. Well, 6 and 4 works, so I've got x minus 6 and x minus 4. So easy to factor, and now I just solve it. So this is x equals 6, and this is going to be x equals 4. And so these give me the x values of the point of intersection of this line with the quadratic. The problem here is that we actually don't know the y values. So we need to sub these in. So I'm just going to separate that slightly. We need to sub these in to one of the two equations in order to solve for the y. So I'm going to sub x equals 6 into, generally the straight line equation is easier to sub it into. So I'm going to sub that in, and then I'm also going to sub x equal 4 separately into the same equation. And again, you could sub it into either and you'll get the same, should get the same answer. So in this one, I've got y equals negative 4 times 6, that's my x, plus 19. If I solve that, that's negative 24 plus 19, so I end up with negative 5. So this gives me the one point of intersection, which is x is 6 and y is negative 5. And so separately, I'm going to do the same thing here. So negative 4 times 4 plus 19. Negative 16 plus 19 gives me 3. And so I end up with my second point of intersection, which is 4, 3. So in this case, I end up like our first situation we wrote down here, 2 points of intersection. So if you look at this, that's not that one. Let me bring the right one up. This is the first equation, and this is the second. So let me just scroll up here. So I've got one point of intersection here, which is 4, 3 in my line and quadratic, and then a second point of intersection, which is 6, 5. And then they go on forever and never intersect again. And that's what our solution told us here. Okay, so if you want, you could try the second one yourself. Again, same setup. So I've got one equation, two equations. I set them equal to each other. And I try to solve it. So I need to move everything over to one side. So that becomes plus 2x, and this becomes minus 1. So again, we try to factor if we can, two numbers that multiply to give positive 2, because I give a negative 2 and a negative 1, and add to give 2. Well, when you think of factors of 2, that's just 2 and 1, and 2 and 1 can never add to give 2. So in this case, you can't factor it. So we need to use the quadratic formula. So I've got my a value, my b value, and my c value. So I'm going to sub those into the formula. So b squared minus 4ac, remember that's the discriminant part of it, all over 2a. So I've got negative 2 b squared, so 2 squared, minus 4 times negative 2 times negative 1, which is my c, all over 2a, and a is negative 2. So if I work this out, I get 4, and then negative 4 times negative 2 times negative 1 is going to be a negative number because I've got 3 negatives, and that's just going to be minus 8. So if you look on the numerator, negative 2 plus or minus this is a negative number. So I'll just simplify one step. And because I can't take the square root of a negative, we know that there are no solutions to this linear quadratic system. So I can't take the square root of negative, so no solutions. So in this case, what that's telling us is that the discriminant is negative, and therefore we have no real roots or no solutions to this system. So that's the other one that I had up here momentarily. So that's the situation where the line is just going north of or up from this quadratic system. Okay, so let's try another one, and then you can see what you've got going on. This one's a bit trickier. If we read it here, it says, if a line with a slope of 4 has one point of intersection with this quadratic function, what is the y-intercept of the line? And then it says, write the equation in slope y-intercept form. So we don't actually have all of the information needed in order to solve this, but what I do know is it's going to be y equals mx plus b. What I know from that equation is the slope, which is m, but I don't know the y-intercept, which is b. So if you remember, the y-intercept is b. So I'm going to leave that like that. I'll call that equation 1. And then equation 2 is just what was given. If we set it up in the same way that we did before, I can have 1 equal to 2, and I can sub in this as my 1, 4x plus b equals this 1/2 x squared, and so on. So if I move everything over, so I've got 0 equals 1/2 x squared, and then subtract 4x gives me minus 2x, and then minus 8, and then if I subtract the b over, I'm going to have minus b. So here we have to think about it for a second. I've got this quadratic. I'm said I need to solve. There's one other key piece of information that's given. We know that this system between the line and the parabola has one point of intersection. Remember, if there's one point of intersection or one solution, there's something we know about the discriminant. So discriminant, which is b squared minus 4ac, we know that it's equal to 0. That gives me one solution. And that's from a few classes ago. So if I think of this A, B, and C, I can use the idea that they're intersecting once in order to sub into my discriminant. So my discriminant given by that symbol, just a reminder, b squared minus 4ac. If I sub this all in, I've got minus 2 squared minus 4, and then a is 1/2. And then I've got this expression for c, which is minus 8 minus b. But I know that it's equal to 0. So I now have an equation with a bunch of numbers and one variable. Therefore, I can solve this. So if I set it up and work it around, I've got 4, and this is going to be minus 2. So negative 4 times 1/2, and then times negative 8 minus b. And you just keep going. So this is going to multiply in. I need to distribute it. So that becomes plus 16 plus 2b. And that's 20. So I've got 20 plus 2b. Oops. Not bb. Plus 2b. And then I move it over. So I've got b, and then I'm going to divide it by 2 equals negative 10. And so that gives us the y-intercept where we have one solution between the two. So therefore, the equation of the line is y equals, and we had 4x minus 10. And so if we take a look at that one, that's this situation here, and it's kind of hard to see where it actually hits. So I'll zoom in a little bit. Again, even then it's hard. If I zoom out, it's hard, but I think it's somewhere around there. So we didn't actually solve that, but we could. And you get an intersecting point just once, which is 2, negative 2. Okay, so why don't you try the next ones? They're similar and should be okay. I'll create a separate video in order to answer those ones if you get stuck. But again, try them out and check out the video if you need to.